So today we're going to talk about graphing exponential functions. Go ahead and take a moment, set up your notes, exponential functions, Unit 4A, Homework 6 with the appropriate date, and set up for questions and comments on the right-hand side of your paper. Take a moment, pause, copy. So here we have our first function, y equals 3 times 2 to the x power. When I graph it, this is what my graph would look like. Once again, you notice little patterns about the graph. And my second function is y equals negative 3 times 2 to the x power. And this graph looks decidedly different. Once again, think back to your exponential function of the past few days. You have f of x equals a times b to the x power. Remember what a tells you, and remember what b tells you. So the first thing I'd like you to do is I want you to tell me how the equations are similar and different. So look at the equations, tell me how they're similar, and tell me how they're different. So we notice that the value of a is going to be different. So once again, here 3, that's my initial amount. Here, negative 3 is my initial amount. Now the value of b is the same. So this is 2 and 2. We know that the value of b tells me whether it's growth or decay. Since 2 is greater than 1, we know that this is going to be growth. So using words like increasing, decreasing, positive, negative, domain, and range, I want you to describe similarities and differences in the graph. So we can say function A is increasing. And even though we said this represented growth, function B is considered to be decreasing. What's the difference that changed that? Now we know that function A is always going to be positive. It's above, it's on the y, all the y's are going to be positive. Whereas function b, it's always going to be negative because all my y values will be negative. Now, domain of this would be all real numbers. It's going to continue going to the left and continue expanding up to the right. Same thing for this one, continue going to the left, continue expanding out to the right. So all real numbers. Now, the range for A is going to be everything greater than 0. Remember, one of the things we talk about in class is that this will never quite hit the y-axis. It looks like it does, but it's never going to quite hit it. And so it's going to be everything greater than 0 for range. Whereas when we look at B, we can see it's going to be everything less than 0. Go ahead and take a moment, pause, copy before continuing on. So let's look at two more functions. Here I have y equals 3 times 0.5 to the x power. And here's my graph to go with it. And then I have y equals negative 2 times 0.5 to the x power. And here's my graph that goes with it. Once again, remember your exponential function, what a would tell you and what b would tell you. So talk to me about how these equations would be similar or different. So we notice that the value of a in each function is going to be different, whereas the value of b is going to be the same. So using words like increasing and decreasing, positive, negative, domain, and range, describe similarities and differences in the graph. So we look at function d, and it's considered to be increasing. When we look at function c, that's going to be decreasing. Now we could say that function c is always going to be positive because, once again, it's above the x-axis, so all my y values will be positive. Whereas function d will be considered negative because it's below the x-axis and all the y values would be negative. We can look at the domain, and once again, the domain will be all real numbers for c and all real numbers for d. And the range will depend on what side of the x-axis. So this one, the range would be everything greater than 0. Here, the range would be everything less than 0. So what I'd like you to do is look back at these 4 graphs and functions and what connections can be made between all the graphs and their equations. What are some things that you might have noticed that I didn't point out? We'll discuss your answers in class when you come next. Take a moment, pause, copy before continuing. So here I have two functions. I have f of x equals 2x with the appropriate table, and g of x equals 2x with the appropriate table. What I'd like you to do is go ahead and graph these. Once again, here's the f of x, which we notice is linear. And here's my g of x with that distinctive curve, which we know to be exponential. What I'd like you to do is examine the values using both the table and the graph for f of x and g of x for where x is less than 2. What do you notice? So here, where x is less than 2, I have an f of x, or a range of 0, 2, and 4. Here, where x is less than 2, I have a range of values for 1, 2, and 4. So I notice that they share the same value where x is 1. And that's going to be considered an intersection point for these two functions. I also notice that they share another value for where x is 2. They both have the same y value of 4. Another intersection point. So once again, as my graph goes up, it crosses the linear, goes slightly below it, and then comes back up, crosses it again to go above it. So f of x is greater than g of x between 1 and 2. So between 1 and 2, where my exponential function dips below the line, that's where my linear function is greater. Now, if I examine the values for f of x where x is greater than 2, what am I going to notice? So where x is greater than 2, look at your values. So this is where I'm going to notice that my exponential function g of x is going to be greater than my linear function of f of x. And it's going to keep increasing at that increasing rate. Go ahead and take a moment, pause, copy before continuing on. So here's your try it out. Go ahead, take a few moments, copy, read, and then answer the question at the bottom. We're going to compare your answers in class when you come next. Good luck, and I'll see you next class.